So in this session we develop a simple oscillator circuit using VHDL program. So look at this circuit. So A is the input, Y is the output. So we have intermediate signals assigned over here with a delay. So normally each and every gate have a specific delay, internal delay present in it. So it may be 1 picosecond or 1 nanosecond, that depends upon the manufacturer. So in this circuit I given T1, T2, T3, T4 and T5 as temporary signal with a delay, and I consider each and every gate has a certain delay of 1 picosecond or 10 picosecond. So let us start programming this circuit and how a simple combinational circuit works as an oscillator. Let us see. So I already created a empty file, so where we will start typing our code. So here I declared the oscillator entity and architecture as oscillator. So I keep A as my input. So initially I keep it as standard logic only and Y as my output. So now we have a new syntax called signal assignment statement. So signal assignment statement is nothing but intermediate wires are declared as signals, which means it is neither input nor output. So that will be declared as an internal wire or internal signal. And the syntax for signal is signal, signal name, standard logic or whatever type we are using. In digital circuits only standard logic and standard logic vector will be the internal signals. So if you want to make some simulation work, so you can also utilize integers, variables, real data type and string also as a signal. So anyway it is internal purpose only. But when it comes to real time, you can utilize only signal if it is standard logic or standard logic vector. So when it comes to design, so I declare the signal. So as per the diagram, T1, T2, T3, T4 and T5 as my signal. So now I declare T1, T2, T3, T4, T5 as signal. Standard underscore logic. So now as per the design, I make the NOT gate circuit with a delay. So for example, initially my T1 will be equal to not of T5. So actually it has certain delay. So not of A. So T2 equal to not of T1. T3 equal to not of T2. T4 equal to not of T3. So T5 equal to not of T4. So now if you want to assign the T5 to Y, you can assign. So first we will check whether it is the closed loop is working fine. And as I said, we have to use the delay. So for making the delay, we have a new statement called after statement. So I am giving 10 picosecond delay, PS. So I assign after 10 PS to make it as a random generation. Since we want to see it as oscillation, I'll give random time periods. So if you want to see at Y, you can assign that Y equal to T5. T5 is already signal, so no need to worry about the input-output declarations. So that's all my work. So compilation is successful. Compile all, simulate. So go to the work folder, select only the oscillator. Okay. So you can see all the signals coming over. Add to your wave, signals and design. If it is there is no any trigger inputs, you won't get any outputs. For example, if you run, you will get only red line. So if you give any trigger inputs, like whether it is a clock, means it will be automatically triggered. So it acts as a simple oscillator. When you keenly see the variations, you can see the delays occurring over in between each and every clocks. So when it comes to design diagram, you can see the connectivities by clicking over here. T3, T4, T5, T2. You can see the variations like that's all. So now a simple closed loop circuit for making the oscillations. Thank you.